On? Okay, yeah, there we go.
Hey, welcome back, everyone. I am very much honored to introduce Jay Taylor, who's joining us from Simon Fraser University, all the way from Canada. And we're going to try and take the conversation about climate change and the technologies of dams from the morning session into a few specific examples and really kind of think about what an environmental historian, as Jay is, has to say about how we acquire knowledge about dams and technology, and then what that might look like as we're turning towards a future with a constant shifting climate. So we're very lucky. He wrote a book called Persistent Calling, Seasons of Work and Identity on the Oregon Coast. So we are also going to move ourselves a bit geographically up into the Pacific Northwest as well. Trained as an environmental historian, he's also a historian of Western North America more broadly. And I don't want to give away too much because I think the answer to my first question will allow him to tell us really kind of how he came to this material. So welcome, Jay. Thank you so much for joining us.
Thank you. Happy to be here.
All right, so let's jump in. What brought you to these large questions about dams?
First and foremost, dropping out of school. I was 20 years old and suffering through a long winter at Portland State University after a year and a half at Sacramento State. And the one thing I knew is all I wanted to do was go fishing and go climbing. And it finally one day, for reasons that don't need to be gone into, I went fishing. Unfortunately, it was halfway through a term and my 18 credits of overload became incompletes and then Fs. And when I tried to get back into school, I discovered I had a 0.8 grade point average. So,
Wow.
But what followed was 15 years in the commercial fisheries, fishing everywhere from Bodega Bay all the way to the Bering Strait, but mostly in salmon. And in the late 1970s, when I really got into the salmon fisheries, got my own boat and got going, my timing was impeccably bad because the oceans were beginning to turn and the runs were beginning to plummet. And by the early 80s, there was almost no season, and I became curious because while I was pretending to be a jock, I was actually a nerd, and there was just no question that this was a big mystery, and a lot of people were asking questions, and nobody had good answers. So that kind of drew me in, and then when I finally got fed up with the life that I'd chosen, I decided to get back into school and deal with the 8.8 grade point average. So that's the answer to how I got into this. And from there, I just asked questions, and I was extraordinarily lucky in that at the University of Oregon with Richard Maxwell Brown and Jeff Osler, and then at the University of Washington with Richard White and John Finley, I had advisors who gave me infinite latitude to follow the questions.
Sounds good. So let's start with those basic questions that you did, thinking about the intersection of salmon life cycles and dams.
Yeah, well, salmon were from the beginning intriguing to me, not just because I'd fished for them most of my life, actually, but also because they don't stay put, they move around, and that causes problems for all sorts of groups of people, for governments. And among the things that we had to reckon with as I was doing the research for this was that they also run into dams. And that opened up a whole series of questions about how across time society had tried to manage these fish and the fisheries and the social and cultural relations around them. And dams were central at the time and have been ever since to these discussions. I guess where I want to start is with a mistake. At the time I was writing in the 1990s, there is a statistic that got bandied around as gospel. And it really goes back to this article in the late 1970s in which Gerald Collins points out in the yellow portion here that Essentially, the estimate was that every dam that a young salmon passed by, it killed 15% of the overall population. And that just got repeated and repeated across time. And it didn't matter whether it was popular writers like Joseph Cohn and Blaine Harden or Richard White or myself. We all just reflexively regurgitated this statistic. I will tell you that when the book was published in 1999, my book at least, that was already wrong 10 years before. What we weren't paying attention to, because of the way that dams seem so fixed in time and space, is that they were constantly evolving, that engineers, that got pointed out earlier by Josh, engineers learn when people die, engineers learn when salmon die. And by the 1980s, they're already devising different screens and deflection technologies, better turbines that, it wasn't so much that the turbines were chopping up little salmon or big salmon for that matter, as that they were compressing them down and creating supersaturated nitrogenized water. And it was the nitrogen bubbles that were actually killing a lot of the fish. And they found better designs for the turbines. All of those things were already altering what dams were doing and interacting with salmon. And it just has continued on since then. So that if I can go on one more slide. In 2001, there's this complex of dams on the Deschutes River, which is in eastern Oregon, on the east side of the Cascades. There are 3 dams there that are owned by, are built by the Pacific Northwest PGE, not Pacific Gas and Electric, but Portland Gas and Electric, that were designed to store a lot of water, especially around the top dam called Round Butte Dam, but there was no fish ladder or anything like that. In 2001, the Confederated Tribes of the Warm Springs Reservation, which is also downstream from these dams, became a co-owner. And at that point, the way those dams were managed changed dramatically, and there was growing discussion, and eventually this monstrosity got built behind the dam. This is known, hold on, I've got to get this out because I always forget the name of this thing, sorry. It's called the selective water withdrawal. And what it does is that every last drop of water that goes from the reservoir behind this, called Lake Billy Chinook, is passed through this facility, and all fish that are sucked up into this are then screened off, sorted for those fish that should be going downstream or those fish that should be staying in the lake. And this was done in part because the tribes wanted to reintroduce anadromous species, those species that migrate from river systems out to the ocean and back. Because there had been historic salmon runs before these dams were built in 1964. It cost, cannot remember now, but it was close to $100 million to build this thing. And everybody stood back and say, okay, now what? When the statistics came in at the beginning of this, starting in 2010 and 2011, monitoring because all the fish were tagged going out, electronic tags, so they would ping at every dam they got passed by. The statistics came back and everyone went, that cannot be possible. It was. And the survival rates are astonishing and have continued to be astonishing to the point now where they now have about 1,000 fish coming back into a river system that before 2010 there were no fish. And this is a remarkable achievement in itself. It's shifted the way I've had to think about dams and their relationship to anadromous species in the Pacific Northwest, which means not just salmon, but eels, sturgeon, shad, and other species. The shad are transplanted from the East Coast, but back in the 1870s, actually. But there are a lot of different species now that are moving up and down these streams, and across time, they've had greater success. So the story of dams, while it seems fixed in time and space, is much more nuanced than that. And that's the thing I've had to begin to grapple with in my own life, because while as a kid I was paraded, in the previous conversation, there was talk about kind of the government that's out of sight is out of mind. As a kid growing up, at least during the school portion of the year in Sacramento, we were regularly hauled off to Nimbus Dam, which was below Folsom Dam, which was a regulating dam, but it was also where the fish hatchery was at the time. So if you grow up in Sacramento in the 1960s and 1970s, you knew that salmon came from hatcheries. That was it. But that was what government did, and this was good, right? Okay. So across my career, I've kind of inverted from dams being bad to something more complicated, but also from hatcheries being good to something much more complicated as well in that respect. So.
And I think all of this fits into your larger questions about changing climate and technologies for dams of the future, right? And thinking about not just the watershed of a particular salmon spawning space, but the entire water cycle. So do you want to, I know you have some thoughts about how even ocean questions connect to this.
Yeah, there are a lot of different questions that connect to this, but the fundamental thing is that I've gone from a position where in the 1980s and 1990s is like dams are the real problem. We've got to deal with these things and what have you too. Dams are now a tool and may be a friend going forward. That's as a general category rather than all dams in any way, because among the things that I completely agree with in the last conversation, I think Mina was the one who said this, they're site-specific estimations going forward.
And I think also for some of us, it's about the process and procedure, like a co-owned dam by a confederation of tribes in partnership with public-private. I would go beyond that, and this is where it becomes Pacific Northwest in particular, because I am based in the Pacific Northwest, and I have been writing about that region my entire career. It's not something I'm ever going to completely wander away from in all this. But it's not just tribes, it's tribes that hold those 1854, 1855 Palmer-Stevens treaties, because they have a real hammer with those things right now. They have, because of a decision in 2018 by the Supreme Court, those treaties even hold an ecological implication to maintain habitat, which is not something that existed before that point in time. So this is the Keeling curve, Charles Keeling's measurement of annual oscillations in CO2 above Mauna Loa. This is when I was first introduced to this, in 1972 in my freshman year at Rio Americano High, which was on the American River, below Nimbus Dam. Even at that point, we were already talking about what this means, not necessarily having any real clear understanding of where things were going. But I was very fortunate at the time to have a teacher. This is back when California had tenured teachers. And Dick Thorne was throwing this stuff at us, making us read scientific theory at the time, but also things like Adam Smith and Ricardo and Malthus and Marx and a whole lot of other things as well. Ninth grade? Well, Marx and that other stuff was 10th grade. It was a different world. And, you know, the public school systems were just radically different at the time. So we're thinking about all this. So this is on my radar by 1972. I now wish I knew in the 1990s what I know now, because I want those last two chapters of my first book back. I would write them very, very differently now. But climate has really become the key part of talking about dams and salmon for a variety of reasons, and I've completely reversed myself in some very qualified ways about dams.
The oceans are changing and changing very rapidly. In fact, I witnessed this from my boat, not knowing what I was witnessing at the time in the late 70s and early 80s. I was on the water in 1982 and 1983 when a super intense El Nino just devastated the salmon runs across the region in a way that nobody could argue that it was anything other than the oceans and all this. They've only gotten more unstable across time, and to give you a basic code here, yellow is not good, red is very, very bad. We've had a series of El Nino and what scientists elegantly refer to as blob developments in the Pacific that create hypoxic conditions. And they've years on end, and this is I think this is the new normal in all this, and it's not a good new normal at all for the fish. And this is completely beyond policy at this point. It's just going, and it's like that super tanker metaphor. This is not something that's going to be turned around very quickly at all. In all this. So the marine environments and marine climate has become one part of thinking about this, and it makes it even more acutely important that we think about terrestrial climates and riverine ecologies and all this. But the way I'm going about this and thinking is that climate is not a straightforward argument because you can have reservoirs that are filled with warm water that just kill fish below them, not only in them, but below them when it's released like that. But not always. And that's going to be increasingly important because this study, it's done by, this is one of those studies that takes, it's a meta-study. It takes a lot of different studies about what's happening to river ecologies just in the Cascades in Western Oregon, and really just 3 watersheds in particular, and thinking about what's happened across time, matching them up with a lot of theoretical and conceptual data, and pulling it all together. And the take home from this study, which is published in Barbara Cousins' The Columbia River Treaty Revisited, is that there really is close to an absolute consensus that the amount of precipitation that's going to fall in the Cascades in the Pacific Northwest is not going to change much, but the form is going to change dramatically, and all the models say this, and this is the same across the West, is the snowpack's going away. That poses real dire threats to fish in rivers because they are already beginning in some places to dry up in really hot, dry summers going forward. And this is where I come back to dams in a very different way than before, because there's also a lot of talk about restoring riverine systems by modifying dam operations. The key thing here is modifying, because increasingly people are now thinking if the dam is built right and operated right, it actually can enhance downstream things, because the key thing increasingly is not just capturing water. Mina was talking about that earlier, the importance of capturing these flash storms and what have you, which is more southwest than it is in the Pacific Northwest. Really, it's still wet for a considerable portion of the year, although not as much as it used to be. But even pre-climate change signals, July, August, and September were pretty dry months in the Pacific Northwest always, but you had the snowpack. We're not getting that anymore. It's going away. So it becomes modifying dams where you can basically tune the releases by drawing from different parts of the different levels of the dam to maintain a thermal charge, not just water, but temperature. And that's the key thing going forward. Can we capture not just water, but thermal? And then manage these technologies in a way. And there's been a lot of research about design of dams, about assessing designs of dams and management of dams across time in such a way that dams can be a tool if put in the right place, built the right way, and managed the right way. And you've got to have that trifecta to make it work. So I am at a point where I am weirdly and surprisingly, to me at least, beginning to argue, I won't be surprised if I see us building more dams, but they're going to look different than the ones in the past. They're going to be in different sites than in the past, and they're going to be used for different purposes than in the past.
If we go back to the question of modification, do you have a sense from these studies of the existing dams that we have, what percentage are even possible to modify in this kind of thermal capacity?
I have no clue what the answer to that is, other than, again, it's site specific. There are dams that were built clunkily. They're just big concrete plugs, and they're not very sophisticated. But the newer they are, the more likely they have multiple ports within the dam to begin to release water. So to the extent that a dam has that capacity, it's more likely to be useful. And a useless dam is a useless dam, whether it's filled with sediment or it just can't do what you need it to do.
I love the evolution of your work as environmental historian towards kind of future thinker of dam construction. And I'm curious, when you work with your students, what questions are you kind of urging them to take on in their own research in the same vein?
Well, my basic advice to all my students is follow your energy. What are you passionate about? Those are the things that are going to help you sustain your energy to pursue whatever you're doing and all this. The other thing is I encourage my students not to be presentist in terms of their asking the questions about the past and to treat the past as the strange place it is conceptually for us. But I also encourage them not to flinch from the fact that there are subjects about the past that speak to the present. In fact, my view has been that the stories we tell about the past are really about telling about where we are now, but also where we're going next. And conceptually, that's a tricky thing to do because the past has all sorts of data points we can look for, and the future's pure projection. Mm-hmm. That's the problem always, is reading from the past to the future and all this, because I'm a person who daily is reminded of the contingencies that shape things. I just got done writing something about some Supreme Court cases in 1911, and I realized as I got through the research that but for the author of Lochner up and dying on the court, a key decision in conservation history would have gone a different way.
I did not think we were going to get into substantive due process, but let's maybe turn to questions on that note. I think Jessica and maybe Bill will help with this side, because we're going to try and slow the pacing a little bit so that we get the microphone to you so we can hear the full question before we ask Jay to kind of.
And I can also repeat it if people.
Yeah, for sure. Should we start there?
Yeah, sure.
Do you want to
Zach,
take him the microphone?
where is the
It's
microphone?
right to your left, right there to your left. I have to turn it on. Thanks.
Thanks so much for this session. I thought it was really fascinating. And I'm really interested in your shifting view about the viability of dams and what it means for salmon, and especially the temperature. And it seems like maybe going forward, that we're going to have a more positive view of dams as a source for power generation in the time of climate crisis. And I just know that it seems like we're on track with new technological developments to really increase the amount of electricity that's being used. And it seems like there's a big push for more nuclear reactors and making that a bigger part. And I know that that can be an issue for water temperature. So I don't know if you have thoughts about that, but if you have any thoughts about how nuclear energy sort of fits into your changing perspective on dams, I'd be really curious to hear that.
Well, the way I come at this is primarily because hydroelectricity is a non-carbon form of energy. Concrete is a carbon producer. So there isn't a form of energy technology that doesn't have costs and benefits to it. And nuclear is too easy to. I'm staying narrowly focused on. There's going to be a lot of habitat that's going to start to dry up. So the primary argument for this is not so much carbon-free energy as a way of maintaining habitat for fish that humans depend upon in all sorts of ways. And, having worked for tribes repeatedly across time on treaty cases, I've come to respect the power of those treaties, and at the same time to realize that the treaties are only for certain groups of indigenous people in the Pacific Northwest. There are other peoples and other landscapes that have less power in these conversations in that respect. But you can make the same arguments for wind. I've looked at the statistics on bird kills and wind farms. It's not good. Or thinking about the costs of rare earth minerals for solar or all sorts of things. Every single one of these is a complicated calculus. Does that make sense? Okay.
Can I ask one quick one?
Yeah.
That thing that you had to get the name out of your pocket, that
Yeah.
screening thing, with those kinds of success rates, has it been replicated behind other dams?
There's been a lot of wait and see in all this, but there's also the cost at the front end. There are two parts of this I want to say. One is the cost at the front end. The second, with those really big dams, you need one of these for each of those turbines.
Right.
And there's a lot of wait and see. There's a lot of basically wait and let somebody else pay for it, also on this. I think it's getting to the point where it's a proof of concept, and then it becomes, can you scale?
Right.
And, that's a really important question, and I don't know the full answer to that.
Thanks. Because you'd imagine you could almost amortize the rise in fish harvests down below if you're getting that many of them through it.
I don't think you could ever amortize it on terms of the value of the fish.
Okay.
On that. I was in the fisheries. We ain't that important.
Okay. All right. Thanks. Others?
Jessica, there's someone here in front. Or two, actually.
I'm interested in climate change versus human demand effects on everything. And in my opinion, it seems like the human demand is the bigger problem than the climate change. Can you comment on that?
Yeah, but when climate is a global problem, okay, and we're talking about global demand. And the United States is the third most populous country in the world, and the two most populous are still trying to raise their standards of living, which means in consuming more energy, and they're going to drive all of this. We could go net negative, and I don't think we bend the curve on this for a while. And by the way, there's this continent called Africa. So I take your point. It's the point I depress all my students with in the final lecture of the term. So it's a really, really important point, and it's not an easy one because this is a wicked problem, because human demand, standards of living are hardwired to energy consumption. Yeah.
I want to follow up on the first question about nuclear power.
Yeah.
Growing up in the Pacific Northwest, the Hanford Plutonium Complex, my real question is how much thermal and other impact it had on the environment, and does a newer generation of small modular reactors pose a different cooling scenario that may not have that impact? And by the way, how do you electronically tag a fish?
Answer the last one first. It's a passive technology that basically it doesn't have battery in it. You're not putting batteries in these little tiny fish, but it's one where there is a weak signal attached to it, and there are monitors at major passage points, especially because of screening. More effective screening means you screen far larger percentage of the run than used to be. And those two things together, because the monitors are right there, the fish are passed through them, they tend to have very high rates in terms of recognizing it, but it's something less than perfect in that sense. So that's the answer to that question. Hanford, very complicated question, very, very bothersome question, because the early drawdowns, there was a lot of thermal pollution in terms of heating of the water. Basically, a nuclear reactor is a very sophisticated steam engine, is all it is. And what you have is heat exchange systems where you're bringing in cool water, passing it around and next to the very, very hot water is designed like a radiator to draw off some of the heat. That drawn off heat then goes back into the river. And the first generation, it was pretty bad in terms of what it was doing in terms of heating up the Middle Columbia River, or at least a stretch of it. That technology's gotten better across time. Neither of those are the real problem. The real problem is all of the waste that was buried out there that is now sunk down because it wasn't contained very well and now is moving in a plume towards the Columbia River. And that's the problem nobody wants to talk about because nobody knows how to deal with it. Yeah. Somebody up here went,
Jacques.
Jacques has a question. Thanks.
I've read a lot of different things about the impact of fish ladders on salmon.
Yeah.
Can you talk about that?
Well, fish ladders, this is a long-term problem. And even in the 19th century, the U.S. Fish Commission was doing all sorts of studies to try and understand what was a workable fish ladder, because the one thing you can agree on was that almost no fish ladders worked well. What they eventually began to realize in the late 19th and early 20th century is that each fish ladder was phenotype specific in terms of the power of the swimming of the fish, the size of the fish. Different fish ladder designs worked for different kinds of fish, but also different sizes of fish. And in the Columbia River, when they started building the really big dams like Bonneville, which was the first dam that was really going to interrupt a lot of the major spawning runs back in the 1930s, and there was no good analysis on what was going to work because the size of salmon ranged from about 4-pound sockeye and even smaller, essentially submature cohos, all the way up to 100-pound Chinooks. And you couldn't design a one-size-fits-all thing. So in Bonneville, there's this myth that Bonneville Dam, when it was first designed, had no fish ladders. That was never really true. What Bonneville Dam didn't have in their initial blueprints was the fact that they had 3 different kinds of fish ladders they were going to try out, and they just didn't draw them in at that point. And they wouldn't know. It was a real live experiment of which ladders were going to work, and the answer was all 3, because different fish were going to pass different ways. They literally have an elevator, a fish elevator in Bonneville Dam that takes some fish up, which actually works pretty well for eels and a few other things like that, but doesn't work for other species as well. So.
Steve, oh, sorry.
They can work. It's essentially what
Yeah, they've gotten much better at it, but again, it depends on the fish. You know. Yeah.
Yeah, thank you so much for your presentation, and it's just fascinating to hear about the evolution of your work and your conclusions over decades. I have a question that I'll apologize for ahead of time. It may be inelegantly phrased, it may be provocative, but having lived in Oregon for a dozen years and having paid some attention to sort of all of the controversy over dams and salmon runs, the timber industry, and then having followed it somewhat now that I'm in California, I mean, it's one thing that has always seemed to be missing to the argument, from the argument, is the sense that there's an attempt to preserve salmon runs by modifying dams and all water levels, et cetera, simply so sportsmen can kill them, or so other groups can kill them and eat them. And it just strikes me as just it never made sense to me fully. I mean, I get the argument, but I just wonder, what are the morals and the ethics and the ultimate meaning of our attempt to preserve these runs so we can harvest or kill these animals? And so apologies if that seems provocative or
Well,
inappropriate.
there's an ethical argument that essentially if you eat things, you care about them more. But at least for the last 12,000 years, There's never been a time when human beings haven't caught salmon to consume them in seemingly very large quantities across time. Who gets to kill? I always get stuck on what constitutes an ethical versus unethical way of killing a salmon. And this gets into the rival arguments about who is the more worthy group to consume all this. And by the way, indigenous people always fall outside that argument. They're the first people erased constantly from the political discourse around this. I mentioned at the start that what I was drawn to, in part because of SAM, was not simply the way they move around, but they put human beings in conflict with other human beings, because these are a remarkably large, remarkably consistent. You can set your calendar when the damn things show up, and remarkably tasty and nutritious food. And human beings have noticed this for 12,000 years. So,
Of the 98% of the salmon that now make it through the dam,
yeah.
what happens to them?
Well, 100% have sex and die.
What percentage gets to the side and not into the food industry? I'm just wondering what their fate is.
That's a fair question, and the answer is we do not to this day have good statistics. We have never had good statistics on this, partly because the 98% that get past the dams to the spawning grounds, whether the spawning grounds is a concrete hatchery or a red in a stream, is a tiny subset of the amount of fish that have been consumed already downstream by fishers, both indigenous and non-indigenous fisheries, let alone that vast pool of the Pacific Ocean where it's not just people trolling for salmon, but people dragging for bottom and midwater trawl fisheries and others and catching them as bycatch. And not just in Canada and the United States, but you have high seas pirates doing the same thing. So the answer is, I don't know.
Yeah, hi, I was curious about, I guess, the experimentation of the Pacific Northwest, of how they deal with not just a fish ladder or, sometimes they truck fish. I was at a Army Corps of Engineers facility in Oregon near Portland. I can't remember the name, but you'll know what I'm talking about. That has a tube and a
The
paper
salmon
plant.
cannon.
Yeah, it was really interesting. And then they talked about the fish sort of to the left, actually kind of archetypal, Pacific Northwest place. But is there always different experimentation going on, like how to deal with the salmon, or is it just like a few, like three, like the modality you talked about with the Confederated tribes, where you have to have one per turbine? Is stuff always going on, or is it just kind of like fish ladders and a few other things?
There are a hell of a lot of people who want salmon around, and they're always experimenting in different ways. There have been ongoing experiments since the early 1970s. There is no scientific rigor to this. I've criticized it repeatedly, but small groups of people on the coast who are basically asking for, like 1,000 eggs, so they can now go and create what they call a hatch box on a little riffle or a stream or a creek or something, so they can try and reintroduce them to these places. And they believe wholeheartedly in what they're doing, and they have never had good numbers on this. But you could say that almost for the entire history of hatchery, artificial propagation, from the very beginning in the 1870s and all this. There are people constantly tweaking and ladders, passage facilities up and down. I'd say policy is itself a site of a lot of experimentation constantly in all this. Every tribal organization in one way or another is trying to get fish back or to protect habitat in various ways, even as they're sometimes also engaged in the timber industry or agriculture or other things like that. It's not, what they're trying to do is have salmon and at the same time accommodate the lives they've grown to develop. So whether you're looking at indigenous groups or non-indigenous groups, everybody's doing that. But policy is the most important place where experimentation happens. Sadly, the most important experiment is trying to cut out other rival groups, user groups. So, the Spokane have basically begun to transplant fish into the upper Spokane River past the falls and other impediments. The Nez Perce are doing this in places as well. They're following the lead of the Warm Springs Reservation. Sahaptin speakers in general are engaged in this all over the place in the Yakima Basin and other places like that. But it's going on all over the place. That book I talked about earlier in terms of the Columbia River Treaty, a lot of it is about getting fish past Chief Joseph Dam. That's probably the most perverse named dam I've ever run into. And Grand Coulee Dam into the upper basin and into British Columbia, where First Nations also want these fish back. But each one of these constitutes a massive shift, not only in terms of technological design of dams, but also of policies going forward. So it gets complicated, especially once you cross an international boundary, but even state boundaries.
On that, you've got a very different geopolitical environment in Canada. Could you speak to the differences with fisheries and other things that are different in the United States and Canada?
All right, the question is there a different geopolitical dynamic in Canada? And to a certain extent, yes, but it doesn't cut in any one direction in this respect. First of all, BC has terrible environmental laws. By the way, it has never actually gone through the land claims process. So that British Columbia is more completely at this point than anywhere else in North America, still having to deal with the fact that you've got a lot of indigenous groups, First Nations up there, who were never treated with and never ceded their lands. So that process is its own moving part that complicates the hell out of everything. It gives First Nations groups certain leverage in all this, and that's part of what's going on with the renegotiation of the Columbia River Treaty, which is actually a power-sharing treaty between Canada and the United States, except that Trump just stopped all that. No, literally, he just said, okay, we're done, because that's the way he solves problems. It's also that what they did was on the Columbia River, what British Columbia did was build a whole lot of very large dams with no facility for passing fish, none whatsoever. So it's a genuine, on top of all the other parts of this, you've got a problem of technologies that in some ways are actually less amenable to alteration than what's gone on down in the States.
I think we have time for one more. Yeah, for sure.
I had a question that has to do with evolving engineering and changing the way we, deal with dams. And with the California Delta project, which was a huge project that was voted down and now it's coming back in a smaller way, I wonder if you could just give us any idea if it's benefited from being postponed.
I know it from the days when it was called the Peripheral Canal, okay? And it never made sense to me then. It doesn't make sense to me now. I'm not sure it makes sense to the people who are trying to farm in the Delta, which doesn't make sense to me. So ultimately it's a way of shipping more water from Northern California or maybe the Yukon from ultimately. That's back on the table. In the end, and at one level, there's a genuine problem with the need for water in a lot of places. And a kind of unwillingness, especially by the Brown family, because it was both generations, of wanting to acknowledge a limit in terms of that. The Sacramento River, the San Joaquin River, the Kern River, none of them are actually naturally running streams anymore that Richard White's concept of the organic machine that comes as close to understanding what's going on. What constitutes the Sacramento watershed includes part of the Klamath and has for many, many decades as well. So, you know, what we have is water moving across watersheds and moving through it in very utilitarian ways. Not only to serve Darth, but to deal with too much. One of the things about growing up in Sacramento was if you got on the highway I-80 and head towards San Francisco, you cross the Yolo Causeway, which in summer is this mile-long dry ditch that in wet years becomes a surging river because it's where they, upstream are some gates that when they open, if the Sacramento River is going to overflow, they just flood the agricultural zones out there. So, you know, it's a very complicated hydrology in these places, but always to deal with problems in a utilitarian way. And yet it's also still an ecology in all this. And every time you divert it, you complicate it all the more. The peripheral canal never made sense to me. That, you know, you can call it whatever you want. It's still, I don't know that it will even work, let alone become a sustainable policy going forward. So, you know, as somebody who's, you know, I grew up with it at a very basic level, I never got it. So I can't quite explain it.
All right, I think we all want to give you a big round of applause. Thank you so much for your thoughts and for all the questions. So we have a little kind of surprise. Jessica